Okay, let's start our today's lecture and continue creating the car game. Previously we created some movements of our car, added a cine machine, virtual camera. Now we are able to move our car forward, backward, added also some wheel movements. Now let's move forward. And try make some different things. For example, I will add a plane and create kind of trampoline, kind of ramp, and we'll try to jump here and see what will be the behavior. We'll add some color. Materials. Material black. And add to the ramp. Now I will try to jump with my car and check what will be the behavior. So now you can see that car almost flies, so it's not really realistic. It flies and it can also goes to any side in the air. So we need to add some air control when our car is not on the ground. So let's now work on this air control. First of all, we need to detect where is the ground. So this is our ground, our plane. And how we can detect it? We can simply create a new layer. Here we have some default layers, and we will click edit layers, and here we'll write ground. So once we created this new layer, we can layers, ground, we can add this layer here, ground, to the plane. So now we know this is a ground, and if we are not on the ground, we will add a different behavior to our car. So what we need to do next is to add some detector for our car. I will create an empty game object inside our car, create empty, and name it somehow. Ground checkpoint, and move somewhere forward. So this empty game object, it's located on a fixed distance towards the floor, towards the ground. So for example, if our car will move up, we know that distance between this object and ground has changed, so we'll know that our car in the air. So we'll detect this distance and distance between the ground. It should be similar like this, and if the car will go up, we are in the air, and add some behavior to our car. So let's move to the script. and create some new variables. The first one, public bool grounded. It's for telling us whether we are on the ground or not. Simple bool variable. Next one, public transform ground ray point, and to this ground ray point we will assign this empty game object ground checkpoint. For detecting the ground. Next, public layer mask. Here will be our layer ground. So we will know what is the ground. What is ground? Next, the default distance between this game object and ground. For example, here it's the distance 0.5, and you need to write something close to this value. Float ground ray length For example, this distance will correspond for detecting our ground. If it will be bigger than this value, we are in the air. So next, let's move to the fixed update, and by default, let's make the boolean grounded equal to false. And then we will check this condition. In order to detect some distances, we need to use function raycast hit. Raycast hit. Here we will detect the distances in this variable. It will be stored the result, and next the condition itself. If physics dot raycast ground ray point, it's from where we go from this point next its position, next where we go, we need to go towards the ground, so we need to go down. Here you can write transform dot. We don't have down, so we write minus transform up, which will mean that we go down. Next, out hit, which means that we will send the result to this variable, whether we hit the ground or not, whether we're on the ground or in the air. So the result will go to this variable, so we wrote here out hit. Next, ground ray length. So the distance of our ray for hitting the ground, this default distance. And next we also need to give an understanding what is the ground, what our raycast should detect. The object we are interacting with, so we are interacting with the ground. And here we'll write if it is satisfied this condition. Here we write grounded equal to true. So let's see how will it work first, and then we will continue our program. What is ground? Here we need to select our layer, ground, and this grounded value will be whether true or false. So currently we are on the ground, it's true. So if I will try to jump, we are not longer on the ground, and now we are again on the ground. So now let's add some behavior. First of all, we don't want to accelerate our car when we're on the ground, and we don't want to rotate it, because when I in the air I still can accelerate it and rotate it. So what we can do, first of all we need to find an acceleration of our car. Here, this is an acceleration. Here we add some force to our car, and we only add this force when we on the ground. So we can simply write if grounded, then we add force to our car. So accelerate only on the ground. And next, the rotation of our car. Where is the rotation? Here it is, transform rotation, and here we use our wheel rotation. So here we can write the condition if grounded and we use vertical axis, which is the left and right arrow buttons. So we want to only accelerate our car when it's on the ground and rotate it when it's on the ground. And so by this we can disable any acceleration and rotation in the air. So now let's save it and check it. Currently I won't be able to jump, so I need to also attach the ground layer to this trampoline ground. Okay, let's try it again. So now the car fell down like immediately when it's went away of the trampoline. It's fell down, and it's not really realistic. It should go a bit more far. So here, jump, and right after the trampoline it's fell down, and we don't need this kind of behavior. We need to go more far. So again, it's fell down right after the trampoline, and we need to go more far. So it's happening because we previously added our sphere. We added some drag force here. For example, if we'll decrease it in the air, our car will be able to go more far. So let me write a script, and then I will explain it one more time. It will be more clear. So we need to control this drag value on the ground and in the air. I'll add additional variable, float drag on ground. And I will get this default value in the start. So I start the program and I will get the value on the ground. Drag on ground equal to our rigid body component and drag here. So our rigid body component is a sphere. So we previously attached to the RB component, rigid body, so we by this rigid body can get access to the drag value. And when we start our program, it will be assigned 5 here. So that's what we can do. So when we are on the ground, we use this default value here. We're on the ground. Here we add RB dot drag equal to our default value, and else we are on the air. We decrease this value RB, drag to some small variable, for example 0.1, and let's check how will it look like. So now I can go more far by jumping. Again, but probably it's too fast, so we can probably need to control this value how far we want to go. We don't want to go so far, so we need to push our car to the floor. So next, let's add some gravity mode, controllable gravity mode, how far we want to go with the jumping. Add additional variable, public float gravity mode, and give it some default value. So when we're in the air, we will add some force to pushing our car down. Again, our rigid body component RB add force simply as we move our car forward. Here we add some force to moving our car down. Again, here we can write vector 3 dot up, and for down it will be minus vector 3 up multiplied by gravity mode and some additional value. Now let's check this one. Here gravity mode value. Now if I go, so now it's a better behavior, and I did 10 here because in order and multiply it here by 100, similar to this case, in order to do not keep these big values here. So we simply increase the values by the script. So now it's a bit better behavior. Again, start. And another thing I want to show you, that for example when we move to the trampoline, our car is still parallel to the floor. Again, I'll click pause here, and what we need to do when we hit some object which has some incline, we wanna rotate our car respectively. So we wanna make it to get something like this when we go to the object, like trampoline track with some incline. So next let's figure these things out and add some rotation of our car towards objects with the incline. So here create another variable similar to this one. And also if you want to focus on some component, you can write F on your keyboard and it will be focused on the component you need it. So F, and it will be focused. So you can zoom in, zoom out. So let additional ground checkpoint, example 2, and for example move backward. Now let's check how we can handle the rotation. I'll create another variable here, ground waypoint, simply add comma here and ground waypoint 2. So now we need to work on some numbers. For example, I will go to the trampoline again. So we need to get a normal of this trampoline with regards to our car. So the normal vector, it's when it's perpendicular to the track. So it's called a normal. So we need to obtain the normal towards this ramp. And that's how we will be able to rotate the car. So first of all, we write vector 3 normal target equal to vector 3 dot 0. It means that it's not rotated, it's like we are on the ground. The basic orientation of the car. Basic. Next, grounded. True. Here we need to write something like normal target equal to hit normal. Next, so if we on a ground, this normal target is normal. And next, here in order to, I will add additional statement if grounded, in order to do not mix them up, and here we'll add another description. Rotate the car to match the normal. So what we need to do here is to change the rotation of our car. Transform rotation equal to quaternion, and next we use function from to rotation. Next, transform dot up. We want to change the transform up of our car. This one we are handling this transform variable transform up, and we want to be normal, the normal target. So normal target and multiply by transform dot rotation. So when we detect some objects on the ground, whether it's plane or ramp, we detect it's normal, we hit normal, and then we rotate our car respectively. and we multiply its value by current car rotation. So let's save it and check. So now it's rotating towards the trampoline. But it wasn't rotated back. Why? Probably we need to increase this value a bit. 1F. Let's see. Probably the probably the first vector is a bit, this checkpoint is too far from the ground, so we not able to detect it. So yeah, currently we are not on the ground, so we need to increase this value or move the object a bit down. Let's better try to increase the value. $175. Yeah, so now we can rotate our car respectively. So next let's add some engine sounds to our car. So currently it's silent and we can add some sounds to it. So how we can make it? We can also simply go to the asset store and search for some assets here, for example engine sound. Here again we can select 3 assets, and previously I tested this one. I already added it to my assets, so now I'll simply open it in the Unity and import this package. By clicking import here. You first of all need to download it first, then you will be able to import it. So now I have some sounds here, like engine sounds, different ones. For example, I will add this one. So what you can have here, you wanna play it on awake when we start our program, it will be played. and we wanna play it repeatedly. So we need to click loop. It will be played again and again. When we move our car forward, we will we'll increment this pitch value, so it will look like we accelerate our car. Engine sound. And I will attach it to our car. So it belongs to the car. Next, let's write some program. He'll work with the audio source, so we need to name it this way: public audio source, and give it the name engine sound. So here we will attach our engine sound. And for example, I will create update. We don't need to make it inside the fixed update. You can simply make it inside the update, create update function, and we'll work with that engine sound here. Engine sound dot pitch equal to the basic value is equal to 1. The default value of the pitch is 1. And we want to increment it when we accelerate our car. So plus our rigid body component, to which we added some forces. So here we use velocity dot magnitude and divide by our max speed, and we multiply it by 2 in order to obtain the whole numbers. So let's save it. I will attach this our engine sound to this variable engine sound. Now let's try to test it. Now our car has some sound. What we can do next, we can also probably currently our audio listener is attached to the camera. For example, if I start the program and I will move this engine sound, okay, first of all I need to change it to 3D mode. Currently it's 2D, so we can listen our engines out everywhere, but for example for games it's better to switch to the 3D mode. For example, you have several cars and you wanna hear them as well, so we first of all switch to 3D mode. Then, as I mentioned before, audio listener is attached to the camera. So for example, if I move this engine sound far from camera, it will be volumed down. If you move it out of the camera, and we can also control volume here. So it's when I move it close to the camera, we can hear it more clear. But what we want to make is to attach this engine sound based on the car. So we disable the audio listener on our camera and we will add component audio listener here on the car. So it will be attached to the car, and we'll make similar things with other car, with another vehicle. So each vehicle has its particular sound. Also in this asset there are some different sounds. For example, let's use this hit sound. For example, we hit some obstacle and we will add some audio understanding for it. For example, I'll create another objects here, 3D object, cube. For example, we will hit the cube and we wanna add some sound to it. So what we'll use this sound smashed. Materials cube. And the collision detects our sphere. Sphere has our collider, this one, green one. So once this collider of the sphere will be collided with other colliders, for example cube, we'll add some smash sound. So I will attach this smash sound as a child to our sphere, because our sphere collides with other objects and I don't wanna play it when we start our program, so I'll disable this toggle. Also I will switch sound to 3D and I will create additional script, script play sound on collision and attach it to the sphere, this script. Attach to one is enough. Okay, and write some program here. Again, I need a public audio source variable, public audio source sound hit. I will touch my hit sound here. Then for detecting the collision there is a default function which we can use, private function, private void on collision, enter, collision, and here we can write some program. For example, sound, hit, play. So once we collide with some objects by this default function, we play the sound. And first of all, let's stop the playing. Firstly, we stop it by default, and once we collide with something, we play it. Let's try to test it. First of all, I need to attach this meshed sound. To our public audio source. And let's try to hit the cube. Also, I will currently disable engine sound, so we will also only hear our hit sound. And currently you probably notice that on start we also had this hit sound because our sphere has collided with the ground, so we also noticed it on the start. So a sphere collided with the floor, and we don't wanna need it on a start. We only wanna collide with objects. So how we can fix it? We can again, for example, we don't wanna collide with the floor, so we wanna add some exceptions to the floor layer, to the ground layer. To this ground layer, it has index 6 here. For example, you can see that each particular layer has its index. For the ground, it's index 6. So what we can add here is simply write if this collision dot game object dot layer not equal to 6, which is the ground, we play this sound. So layer 6 not equal to layer 6, which is the ground, we play our sound. Let's test one more time. So currently we didn't have this sound when we started our program. Now we only have it when we collide some objects. But probably this sound again is similar. But for example, we wanna make this sound different in order to create some diversity for user experience. And we can change the sound also by modifying this pitch value, so it will be different again. So let's make some diversity. Previously we learned the random function, so what we can do here is write sound hit pitch equal to random dot range, and here's a value from 0.8f to to 2, for example. Okay, from 1 to 2. So by this simple function we can create different sound effects on the collision with objects. So now it's 1.6, 1.8, so it's probably slightly different again. Okay, let's return this sound back and play everything together. Okay, that's good. Okay, that's probably everything I wanted to show you today. Any questions on today's lecture? Okay, I'll also save it and upload changes to the GitHub page. Is there Unity car game, local changes, so you need to stage all of them first, then write commit subject, for example, part 2, commit these files, and push them to the GitHub page. Push. Now we'll be able to see these changes online. So here, yeah, the part 2 created 25 seconds ago, so we can create a clone of this repository, or you can download it. You can simply check any scripts here and other things. Yeah, here, what we created today.